So hello everyone, in this video we will see how to cover MPMC Module 5 in a easy manner while covering all the PPTs, the required videos, the portion of the book and like whatever you need to master it, and we will do it from scratch. You don't need any basic knowledge to master this module except the prerequisite of knowing the previous topics of Module 3 and 4, which were of 8051 and which gives a basic understanding of how to do coding in that, basically in 8051 in assembly language. Okay, so let's get into the video and we will see how we can cover it in the best possible manner. So this will be the guidance session for that. Okay, so let's go. Okay, so let's see the syllabus first. So till now in this series we have covered module 1 2 3 4 5, and now we are going, sorry, module 4. So till this we are done, and if you have thoroughly followed the series and try to implement it as much as you could, so you would be probably better off than a lot of the people in MPMC, and you could see that. But okay, so yeah, so after covering having the prerequisite of 8051, we will move to model 5, which comes with LCD, LED, keypad, ADC, DAC. Okay, so I will divide it into various subsections. Okay, let's see that. So the index goes like this. The first question could be from LED, or it could be from LCD, or it could be from keypad, or it could be either of these. So if in morning shift they put ADC, there could be DAC in afternoon shift. So it was that trend before, and now there are various set of papers being asked. So something like that. So, but one thing is for sure. If they're asking ADC, they won't ask the DAC. Uh, so a total 10 marks question could be either from ADC or DAC. And if they're very going very something like that, so they could give it from 5 marks to make the paper harder or something like that. So, but yeah, you can understand it is these topics, these two subtopics are from say like related. So if examiner is setting a paper, he will either ask this or this. Okay, you can get the vibe, right? Okay, so let's get into it. So basically, after we have seen 8051, now we are seeing how we can do some useful work to it. Okay, so we can send 01 in the port, and that 01 can simply be reflected uh, as a LED. Like if you want sending one, the LED could just you know uh, glow, starts glowing, and if you send 0, it just stops giving its light. Okay, so you can give a series of 0 1 0 1 1 1 0 something like that, and you can blink the LED in various kind of ways, and that is how you see various lightings are being done, the coding, embedded coding is done, and all of those are very high complex version of the basic thing we are doing right now. Okay, so that's how this module is very interesting to know how we can do some design of things. And if you could know the LED and stuff, you can if you have a lot of LED, you can generate a sine curve in that, and a lot of things are there. Okay, so yeah, we'll see that. And okay, after LED, we will see LCD. So LCD is in your lab you have seen a small rectangular display. So it's just a display of whatever things are going to be there. Okay, so yeah, there will be a cursor, there could be displaying of your name, like Satya's YouTube channel, subscribe and stuff. Okay, so you can display whatever you want in LCD, and that's how it displays our work in embedded codings. If you go on the left side, there is a small panel there. You could see where the lift position is: floor 1, floor 2, floor 3. So basically that displays of LED and sorry, LCD, and the coding is done to show the numbers in that thing, and we will see how that works. Okay, so that's also very interesting thing. And keypad, keypad is basically used for input. Okay, so LCD and LED are for output, and keypad the keypad is for input. Okay, so if you just type it some out, and it will process the thing. So basically you can take it like this: I give two numbers in keypad, 12 and 63, and the processing of multiplication will be done, which you have already done in 8051 programming, and that output will be displayed in LCD. Okay, so yeah, That is how basic things work, and that this can be modified into various uh, embedded system or something like that, like you see in remotes and a lift panel and stuff. You press the switch, some processing is done, and then it is displayed in panel. So it's very interesting. And DAC, ADC are basically analog to digital, digital to analog converter. So we will see into that. So that's how this module 5 is divided into various subtopics, and that's how important and how intriguing and interesting it is in real life. Okay, so if you get the vibe, get the feel, just comment it down, and uh, yeah, and just give me like if you like the analogy and the way I made it interesting before even starting the module. Okay, so now let's get into the each topic and sub topic which are being covered in PPT, and that's what I have covered in my notes. A few things like one two subtopics of video you have to watch extra, otherwise everything is there. Okay, so let's go into the video. Sorry, go into the notes. So LED blinking. So this is the link. Okay, in resources, 50% contribution is done by engineering funda, and rest of the contribution are made from video, PPT, classes, doubt clearing from teacher, book reading, and all stuff. So I have done a lot of things. I have given 150 hours to MPMC, and just get it. So LED, the best possible video will be this, and there are few extra notes I have written here. So I will just go through the notes. I have given an overview. The basically the resource, the guidance resource is this. So like its subtopic, we will have its link if needed and stuff. Okay, so let's go through it. This link is there. Blinking all LED. It was made by Engineering Funda, I guess. So how to blink eight LEDs. Okay, so there are if you send 112 every pin, the all the 8 LEDs will go. If you send 00, all it won't glow. Okay, so if you send a series like first one, or if send all one, then you send all zero, though, so the blinking will be done, right? So yeah, uh, here I have divided into various in LED blinking also I have made various categorization of whatever I have noted down. So blinking all LED. Okay, then there comes in LED you need some delay which will be useful to make various patterns and stuff. Like, okay, so uh, you know give you turn on a LED. After 2 seconds you turn it again. After 3 seconds you turn it again, and this pattern, if applied to a lot of LEDs, it can generate a pattern, right? Like sine curve and stuff. Each point will be have blinking at some interval of time, and there is a lot of calculation, right? Okay, so coming to it, so that is why delay is important. And delay, I have it was required for timers and stuff also, so I have uploaded for your cat one as well. So the separate only delay portion was I have given there, and that same delay I have put it here. Um, okay, so there in delay you should understand delay using register, delay using timer. Okay, and here we will see timer and counter we are already done with previous modules like module 3 or something it was there. So that portion is completed. Now at register I have also uploaded this same portion now, but in LED you need to do it with registers. Okay, so you can do it with counter as well as we'll see. Okay, so using register, there are two types of questions. There are two type of cases basically you have to handle whenever the crystal frequency is 11.05 and whenever the crystal frequency is 12. Okay, so there is a slight difference whenever you calculate the time. There is a difference of 0.8 seconds. So basically in both the cases calculation of a number of loops you have to make will be same, just you have to show it differently by using the calculator, otherwise the calculation will be same. That is what I have written here. And okay, so these two cases are there. After I am saying this only because after analyzing all the POIQs. Okay, so if any other frequency comes, you should know the basic way to do it, but generally it won't come. Okay, so okay, let's move to it. So delay using register for 0.5 second will be happening like this. You just go through the video, you will be getting to understand this in a lot easier way. So delaying we can generate from uh, 5 second delay to this, we can come to this, and after, if you multiply it by 2, we can generate 1 second delay. Okay, so putting various loops, we can increase the number of delay, and that's how I have color coded here to show it to you, and it will make your understanding very very easy. Okay, so yeah, there are various that's how a 1 second delay is generated, and in question the generate comes after 10 second delay or something like that, so you can put another loop over it and just multiply it by 10. So that's very easy, right? Like I have done like from 1 point uh, from 0.5 second, I've just multiplied 2 microsecond, and some this is done. Okay, just get to it. Okay, and uh, for example, I wanted to make 123-second delay, so I can multiply 123 into that inner loop of 1 second and simply get this. Okay, so we will focus on this uh, thing and stuff. There's a little bit of doubt I haven't cleared that time. So you can, if you're done with everything, we just can go through it. Otherwise, without clearing that as well, I guess you can just make it through. It is not a very significant one. Okay. So yeah, to delay using two restaurants stuff. There is a syntax. Why you want to write um, 0ff and not ff. So it's a convention that just remember it. It's a convention that um, before the letters in hexadecimal representation, you just put a zero. Okay, so yeah, that is why I have written there, and there is a lot of things which you shouldn't do. So I have highlighted that as well. So yeah, this is the simulation which you can do to practice and to see if your code actually works. So there is a video I have attached here, so you can use Proteus. I highly recommend it. It's not needed, I guess, because in syllabus Proteus software uses is not required. But for your understanding, I recommend download it, do your coding, and see how it works. Okay, so you will be more comfortable in coding after you see it, that your code actually works. And if you can do code it and actually run it, you can write in paper easily, right? So yeah, so for your own understanding, you can do that. And there is a various connection which is also used in coding. If you do practice in simulation, it will help you out to write the code in paper as well. Okay, so yeah, the blinking of LED or LED are blinking, or LED are blinking, and here all LEDs are not blinking. The same question. Okay, this one. Okay, if you want, I can put it outside. Okay, then blinking is single LED. In that case, I told you how to. Oh, you know blink all the LED at once. Here I am talking about single LED. So here in single LED, don't give signal to all the LED simply. Okay, so just pinpoint a single pin and give put it as set or clear to give it 0 and 1. Okay, so yeah, you can go through it. It's a simple code and stuff. Okay, so there are two LED blinking phases I covered, and there is Proteus download thing there. So yep, you can just go through all the videos and stuff. There is this Hindi video as well, which I guess it's Hindi. I don't remember, but yeah, it's good. That's why I attached. Okay, so yeah, out of lot of videos out there in YouTube, I have segregated what actually helped me to understand the topic from scratch. Okay, and by scratch, I do mean you need to know module 3, module 4 prerequisite of coding. Otherwise, this would be too hard. Okay, so let's move to LCD. LCD, here is a Hindi explanation, and there is another explanation of the exact code which was or in PPT, and there are a lot of resources. So after watching all this video, I get to know it clear in mind in rough, and I just made the formal notes here. So yeah, I referred engineering funda sir as well. So yeah, let's go to it, and these are the from PPTs. So you're actually covering your PPTs as well. Okay, so LCD, there is a LCD display, so there is 16 this much sections there, and each section you could see a lot of smaller pieces, and these things just glow out like this to give you a letter which you can see in elevator and other railway station and stuffs. And yeah, so this is how it works, and this is how it is seen in real life. Okay, so yep. and all these pins you have to remember for sure. You have to remember it. Okay, except this thing which is not used. All the pins you have to remember, it is needed for coding. Otherwise, you can't. And this is the connection you have to make. If this connection is needed because you need to understand the connections to put it in coding, like which signal you want to give to which pin and stuff. Okay, so this is the table you have to remember for LCD commands. Okay, and all those stuffs. And here is a cursor detail. If you put this, your cursor will come here and stuff. Okay, so yeah, you have to remember all this thing. There's no doubt, in paper they won't give this chart or something. You have to remember it for coding. Okay, so this was mined out. I don't know if it is relevant for your syllabus or no, not. Okay, so Proteus again here comes with that thing. uh yep, Proteus, how to uh, do it in Proteus. Uh, then we come to normal method, or where we will do coding for LCD interfaces. And here you can see the code with the comments, like the theory and code both are attached here. And there are basically two methods of LCD to code. One is normal method, and second one is DPTR method. And these two videos should work. And this should these two video. After watching these two video, you will be done with the DPTR code understanding. And here's the summarized version of all the video. And basically, I just showed the final code with all the comments down there for the revision. Okay, so yeah, this section, this section, this section, and done. So here are the connections. So LCD done. Now we'll see the keypad thing. So yep, you have to watch first this video and then this video, and one of the video won't be sufficient, so you have to watch both. And after that, you can understand the notes. These are from PPT. I have written down in summarized form. And yeah, and this thing, this D0 to D7, you have to understand how the message is given. And here the required theory in a summarized form. This is the flow chart, which is useful for coding in keypad. And yeah, this is this is the switch bouncing thing, which you need to understand, but you don't have to remember these graphs probably. So yeah, you can skip that if you want. And this is the prerequisite which you need for keypad thing. And here are the theory and codes. This again the comments for each line of the code which I have made. And yes, there are subsection. Here I have divided the code into various subsections as well, like lookup table, then delay, and all stuffs that will help you out to remember things. So yep, we have covered with the keypad, and now we'll move to this section of ADC DAC. So in this thing, as per the previous year questions, you can see these things of square wave, triangular wave, cosine wave, sawtooth, and probably they won't ask you this directly. So there could be chances of mixture of waves. Like first make one square wave, then triangle, then sawtooth, and like that combination will be repeated. So yeah, if you do this basic waves, you can make uh, those complex combination mixtures as well. So yeah, I do see out the PYQ for that thing. And ADC is very less important. If they want, they will try to give you the DAC first, and ADC they will prefer less. And yeah, um, there is not much enough resources for ADC, and this is the best possible thing which I could put out, and I just wrote in that. And if you can understand it, well and good. Otherwise, yeah, you can just total this, because a lot of resources are not available for ADC. Okay, so yeah, there is another video link attached here to understand this thing. And yep, the only two videos are left for ADC, which I have attached in the resources section, so you can watch that to complete if your understanding of ADC. Yep, so we are very much done with this thing. So totally model 5 is done, and by completing model 5 we are done with the total 8051 thing. And yep, in next video we will see module 6 and 7, which is basically of ARM and ARM coding and stuff. So we'll see that in next video. So till then, stay tuned and do let me know if this video helps you out. See you.